Hello, everyone. My name is Jiayi Chen from the University of Waterloo. I'll be presenting our work, Sharing Without Scaring, Enabling Smartphones to Become Aware of Temporary Sharing. This is a joint work with Dr. Hengartner and Dr. Hassan. Temporary device sharing is a common activity where a device owner shares their device with another person called a sharee. People share their devices for help, convenience, or social purposes. For example, people may hand their smartphones to their friends for sharing videos, or they may ask a stranger to take a photo. However, device owners have privacy concerns since sharees may access their personal data or perform sensitive operations. To prevent unauthorized access, owners may supervise the sharing process or adopt sharing protection solutions. Because device sharing is also a social activity, its social implications, including trust, relationships, and the impact of the cultural differences, also affect people's sharing practices and even the design of the sharing protection solutions. Existing sharing protection solutions mainly focus on access control. For example, guest accounts provide sharees with an isolated environment to prevent all access to the owner's data. But it is not so convenient to share single files. App pinning is provided as a system feature on Android and iOS. It allows the sharee to access the current app only. Vault and App Lock are the common solutions on the market that provide fine-grained access control over single files or apps. They enable owners to hide sensitive resources and enforce authentication before they access. However, many of these solutions require manual activation before device sharing. An owner may fail to enable sharing protection for many reasons. First, device sharing is usually casual and unplanned. An owner may forget to enable the protection before handing the device to a sharee. And sometimes people are even unaware of the risks of exposing sensitive resources during sharing. More importantly, explicitly hiding information may signal mistrust to the sharee and lead to negative impact on social relationships. To avoid these situations, a desired sharing protection solution should be able to proactively and automatically detect a sharing event and secure sensitive resources. So, we propose device sharing awareness, DSA. The key of DSA is to determine when to activate and deactivate sharing protection. Here, we use a state transition diagram to describe its behavior. Initially, the device is in a normal state, indicating that the owner is currently using the device. When a sharing event is detected, the system moves from the normal state to the sharing state, and at this state, the sharee can only access non-sensitive resources. And after the sharee finishes using the device and returns it, DSA needs to verify the owner's identity to move back to the normal state. The locked state is entered in two situations. One is that a sharee performs any potential violations, like attempting to access sensitive resources. And the other situation is that the owner manually leaves the sharing state. In both scenarios, a user is required to pass the user authentication to leave the locked state. And next, let's move to the details about the sharing detection. First, we propose sharing gesture detection to capture the owner's actions that indicate a sharing event. In DSA, we focus on handover gestures, where an owner passes the device to a sharee by hand. So DSA collects the motion data from the built-in motion sensors and extracts both time domain and frequency domain features over segments. There's an overlap between every two consecutive segments to cover the handover patterns. And then we apply a sliding window to perform detection over multiple segments to reduce the false detection rate. The handover model needs to distinguish handover gestures from other similar movements, like device rotations or single user switching hands. And to reduce the user's efforts in training the handover models, we choose to pre-train a model that works across different users. Moreover, we adopt the adaptive sensing to reduce the power consumption, where the handover detection is only activated when a significant movement is detected. Next is the owner detection. The basic idea is to verify the owner's identity to confirm that the device has been returned to the owner at the end of a sharing event. We use behavioral biometrics-based implicit authentication for owner detection. It enables DSA to distinguish users based on how they swipe or type on a touch screen, and perform continuous and transparent identity verification in the background. In addition to ending a sharing event, the results of owner detection have different implications based on the current state. It helps DSA to handle exceptions. For example, detecting a non-owner in a normal state implies unauthorized access. Also, it can help correct the false positives of sharing gesture detection that falsely enables the sharing state. So based on the modules mentioned in the previous slides, we implemented a prototype DSA service on Android. It is running in the background to continuously detect the sharing event, and once the DSA enters the sharing state, it will enable the app-level access control and hide the notifications from sensitive apps. At the same time, it can also interact with the other apps, like notifying the current foreground app of the sharing event. And for example, so this gallery app can just receive this signal to disable the sensitive operations like deleting or modifying a photo during a sharing event. To evaluate the effectiveness of DSA, we conducted a user study with two parts. The first part focuses on the performance of handover detection. We collected both handover and non-handover data from 18 participants and 5 different phone models. We measured the precision and the recall rates of the cross-user, cross-device models under different settings. In the second part, we tested how well DSA handled the complete device sharing events. We used the pre-trained handover detection model and adopted touch-based IA for owner detection. 10 participants performed the web page sharing tasks in pairs and contributed to 50 sessions in total. Here are the results of our study. For the first part, we showed handover detection results in terms of the precision, recall, and inference score. We investigated the impact of the segment size, interval, window size, as well as the activation threshold for adaptive sensing. And eventually, we obtained the best settings that achieve a balanced precision and recall rates. As shown in the box, the overall precision is about 98% and the recall rate is about 95%. The average detection time was about 2.33 seconds after the owner starts to hand the device. And it shows that DSA could enable the sharing mode right after a sharee took the device. In the second part, we recorded the traces of DSA handling the sharing events. And this figure shows one sample trace. And we can see that the owner was initially using the device, which can be reflected by the owner detection. And after DSA detect a handover gesture, the system enabled the sharing mode. And while the sharee was browsing the web page, the owner detection kept track of the user's identity. And only after the owner's identity had been verified, the system moved back to the normal state. So in total, DSA automatically and successfully handled 41 sessions without any exceptions. And in the rest sessions, DSA can correct 7 of them with the help of owner detection. Okay, so in the end, I would like to quickly summarize our work. So in this paper, we proposed the device sharing awareness DSA and provided implementation on Android. And our user study showed the effectiveness of the DSA in handling and sharing events. And we also released our data and source code of DSA as a link shown on the slides. For future work, we would like to extend the sharing gesture detection to cover more edge cases. And also, we would like to conduct a long-term user study to collect more users' feedback. Okay, so this is the end of the presentation. I'll be happy to answer your questions. Thank you for listening.